characteristics. Now it has evolved with 5 characteristics, right? Like a 3 characteristics. One is volume, size. Second one will be variety, type of data, that is structured and unstructured. Challenging is unstructured. Even big data is only went for unstructured, not for structured. Structured data, in doing things structured data, we don't want to require any specific or special tool or algorithm or any specific things to do it, right? So that is more enough to do this. And third, we talk about the third B, that is what is called as velocity, speed at which the data is arriving. Like in earlier, in the past, before 5, 10 years or before 15 years, you can see the data. I mean, the per day, even the Facebook is generating only like hardly 1 TB of data, but now it is more than petabytes, more than petabytes of data. I mean, it is the data which we are getting even from only Facebook is little bit large. Similarly, you can treat about all the online applications like Amazon and Flipkart, whatever let it be, and the data which you are getting from that is little bit, I mean, little just too large. That is what the term big data also is came, right? So this is the third V. And fourth V next, which is added in the later period of time, it is called veracity. So veracity means like finding mind the missing. I mean like what is a noisy, if what is inconsistency of that data. If I have a data field or if I have a data set and if I'm trying to do something with my data, if I find the data irrelevant to it or a data which is not conveying a proper meaning or a data which is in error, which is not producing the right information, that is what veracity, removing all those inconsistencies from the data set. And the last V is the fifth V is the value. Whatever the data that I get from this analysis should be valuable data. So that data mining is that is which will be doing the task with this, like extracting the knowledgeable information. Whatever I've given a huge data set for you. From this, you need to extract what is the knowledgeable data. I mean the data which I am in need of, or the data which gives me something, some good sound for me to do with the task. That is data mining. So data mining is a process of extracting, I mean mining, extracting the knowledgeable data from the data set. It is the meaning of data mining. So it is the, I mean like it is a relation between all the 5 terms like data, database, data mart, data warehouse, and data mining. So after all these terms, now it is, I mean, then it is shifted as big data. I mean, where the huge set of data is termed as big data. Then the term came data science, and right now we are working with data science. So this is the evolvement of from data to data science, right? So data warehouse is an organized collection of integrated subject-oriented databases. It means, what is a subject-oriented databases? It means, if we talk about a student database system, my data warehouse will be storing the data related to student repository. I mean related to student details alone, which will not be holding some other things like bank details or some other things which is not related to that application. That is what the first meaning of it. And data warehouse supports reporting and data mining activities. And the other thing is like this data warehouse is also important, is also plays an important major role in BI, business intelligence. Like how it is helping in business intelligence means like it is help, as I told you, like if a proper good decision, when it is a good decision, it should be in terms of data driven. It should not be in terms of like relation driven, right? So I like if as being a team manager, team leader, if I'm taking a decision, it should be taken in such a way that it should based on the data or the past data. In future, in uncertain, like uncertain in future, it should not lead to any other kind of misconsistencies. Like if I talk about a risk, whatever the, I mean, like when you do a project and the things are unexpected, you can see some rises, you can see some falls in the middle. It can be unexpected. If I have a proper decision making tool and if I follow a proper strategy, then it is sure that you will not be getting falling into those risks, right? That is what the meaning of it. That it is, and also it should be noted that only by having a standard tool, standard decision making tool, it is not that you will be getting into failure. It will be helping you to overcome from failure. It will be helping you to avoid getting failing into failures. That it can do. So let us come back to like how data warehousing is helping in business intelligence. I mean, like if I want to make my intelligence, I need the data warehouse support. It helps me in making a decision making to be get improved in terms of data driven, and that is the use or that is the support of data warehouse. Okay, next. So design considerations for data warehouse. When you start about a data warehouse, what are the design considerations to be made? So first and foremost, as we come in, as we explained in the last slide, like a subject oriented, that is the first and foremost subject oriented, which makes the data warehouse to be effective. Second, integrated. How far my data warehouse, I mean, which is integrated within my subject area. And third one, like a time variant, like whatever the data warehouse, the data we collect. For example, you can take the well-known thing in Bangalore, like DMart. So DMart, whatever the data that they collect in a day, I mean, before getting into the next day, they should get into an end. I mean, like whatever the data that I've collected today, I should analyze what is that done today. I mean, like at the end, what is the business I made? What is the profit that I got? And what is the number of items that has been sold? And what is the number of stocks which is available in the market? At the end of the day, I should come out with a solution. So this time variant, like a time series, whatever the data that we use, either it should be get updated on a hourly basis or on a weekly basis or on a daily basis. And whatever the analysis that you do on it, either are you doing it on a hourly basis or a timely basis or a weekly basis. Some application requires this to be done in time minutes. Some application require this to be time and done in hours. That is what this time variant. And non-volatile. And I hope you know the difference between volatile and non-volatile in terms of like related to computers. And here it is little bit small different. I mean, like if it is non-volatile, if I want some kind of data items to be get stored on my database or on my data warehouse, I should not be like as of this now. As of now demand I need a database. I'm creating a database, and I'm just trying to hold. I'm just trying to store some data into it and processing it. But later period of time, I don't want this. I shall be removing it, and I will be getting into a next one more database which I'm doing it on my now. So as of temporarily, I should not create and make use of data warehouses temporarily, right? Only it should be done when it is practically needed. When you want to do something with some kind of analysis with the data set which is given for you. That is what this volatile and summarized. Like so, as we know, what is the task of and job of doing analysis on this queries. So what I can do is like a number of variables and dimension that whatever my data warehouse is required to be. And if I talk about a data warehouse, what is the data? I mean, how the data are being going to be get represented. You need to have an idea of it before designing the data warehouse. And mostly the data warehouse that we consider we often will be non-normalized. And non-normalized, what is the meaning of it is like using a schema. And schema, we all know three schemas, level know three schemas like a star schema, snowflake schema, and fast constellation schema. So this we shall be discussing in the next upcoming slides about in schemas. And metadata is a data which stores or contains information about other data, that is called metadata. And last one will be like near real time. So whatever that we do should be relating or correlating with the real time data set. It should not be just talking or passing about only with the historical data set, right? And next, so as data warehouse architecture, so before getting into data warehouse design, we have seen the considerations for a data warehouse design. Once this is met, we will be getting into data warehouse architecture. Here we have four terms like source, transform, data warehouse, and using, I mean, accessing it, right? So I can you can relate one more term called ETL, extract, transform, load, that you should be knowing in like data warehouse. ETL, OLAP, OLTP. These are all the terms that you should be aware when we get working with a data warehouse. So data sources, like of what are the sources that I'm getting my data from my data warehouse. For example, if you take our institution ERP system like Acharya ERP system, so Acharya ERP system will be helping you to come out with few things like you can know your attendance through your ERP system, and you can get your data through ERP system. You can apply for revaluation. You can see your fees details. You can, even if you want to be advanced, like you can get all your results. You can get all the things to be get solved in a single ERP system. So for that, where the data is being collected, from where the data is being passed, it is a single data warehouse. If I talk about only a Acharya Institute of Technology, it is a single data warehouse. Similarly, if I talk about it is single database, right? If I talk about Acharya Institute, then the data warehouse comes. So data warehouse is Acharya Institute, and in this I can talk about the data mart. One will be Acharya Institute of Technology, and one will be Acharya Institute of Management Sciences, and one will be Acharya Polytechnic, one will be Acharya Engineering. It can be of like this, like in this way you can treat. So from where I will be getting all the data from each and every, I mean from each and every database, I will be getting a huge amount of data. and that I will be working on it, right? That is what data transform. So before data transforming, I need to pre-process my data set. Pre-process means like cleaning my data set, making my data set data to be free from errors, to be free from noisy data. Noisy data is like irrelevant or missing data, or a data with missing information. It is called noisy data, right? So data transformation, I will be pre-processing it. I will be selecting my data, whatever that I need. Then I will extract, then I will compute the things. Now this will be fed into my data warehouse. Now once it I do this, this data will be getting passed into the central warehouse repository. So where I can start doing my analysis. So this data warehouse will be helping you to store and analyze, process the data. If you want, if we are trying to mine something, or if you're trying to do some kind of analytic something from that, then we will be relating data mining tools into our data warehouse application. So that's what the last one, like accessing and users and applications, like reporting tools, dashboards, queries. So this dashboards that we have talked about a dashboard even in business intelligence. I mean the first topic of this module 3. So how this dashboard is helping in BI. I mean conveying the things in an intelligence manner. I showed you a small example with the chart and representing one table and just like a graph. So this is one small example of connecting this to that top BI. Right. So the first element that we talk about sources, which provides you the raw data element. Since raw data element can't be get into our data warehouse directly, we need to pre-process it. We need to do some kind of task to make our the data fits to our data warehouse repository. That is the first thing. And second, once it is done, like a transforming, and here you can make use of like extract, transform, load. And the third one will be like I mean like data. It is a enterprise. It is an enterprise data warehouse. It can be a data mart, or even it can be ERP systems. And the fourth one will be from where you will be trying to access the data. And make sure that you're not going to mine, or you're not going to do any kind of analytic from it. So when I talk about those things, I'll be getting into data mining. So data warehouses, I can get data from multiple data warehouses. See, I told you an example like Acharya ERP system, right? So that is also same thing. Like it is talking about ERP, all business applications, including ERP systems, IT systems, and about even the customer orders. If I talk about retail system, I told you about retail system in BI, right? So retail system will be doing two things, which can track both in terms of which can track the data in terms of both online and offline. May talk about an retail system. I will be tracking about the seasonal item and the most selling item, and the items which is not at all sold, like unselling item. And I can track about associated items. Item one item is getting purchased. What are chances of other items also getting sold along with the same item, and what are the other strategies being followed in this? That all those things, all the data sources. And second, POS terminals. If I apply a transactional database, I will be using all this as POS. And third, where I will be connecting these things with any of the external data set, data warehouse repositories. If I need to some kind of data warehouse, like if I'm trying to find some kind of prediction things, I need also my thing to be get related to weather. If I'm trying to, like, for example, let me take like if I'm trying to provide a smart data warehouse repository for a smart city or for a smart traffic, then I need this to communicate even to the like this also should be get communicated to all the traffic data warehouses across the city. And if it is required, if the traffic is also big, if it is required to be done in terms of like when there is a heavy flood or when there is a heavy rainfall in it, and if you want to make the traffic to be even efficient in those time periods, you need this to be get connected to external data source. That is a small example for external data source. Like as I told you, ETL, you can see like data transformation works with ETL. So data should be extracted from an operational transactional databases on a regular basis. Second, once the data is being extracted, you should make sure that it should not have any irregular or missing values in it. You should make sure that it should be computed in such a manner that it is having a proper level of granularity. And third, the transform data should be then uploaded into data warehouse. Once everything is done, then it will be getting into data warehouse repository. Once it is getting into data warehouse repository, then their data mining starts. So once we complete this data warehouse, we'll be starting with the data mining shortly. So data warehouse design. I told you right. We have talked about a schema in consideration of data warehouse, right? So in schemas, mostly we will be using star schema in data warehouse design. Star schema. So when comparing to all the three schemas, this schema is little bit well known and familiar with all the data warehouse repositories. And what is the thing is this as a central fact table and which is get connected to all the lookup tables. Lookup table provides values for codes and values for the central table queries which they pass. I'll show you a small example in the next figure. And the other well-known schemas are like the Snowflake architecture is also can be used, but the difference in that this will be having this will be having their own lookup tables in Snowflake architecture, and we will be using this as star schema in the data warehouse design. So this is a data warehouse designed for a star schema architecture. Like the central, you can see orders data. This orders data will be the central data for this data warehouse repository architecture, right? So in this, I can see that item ID, salesperson, region ID. If you talk about item ID, that will be connecting into the other table, item ID and item name. So all these are four corners are called as lookup tables. This central table will be get connected to all the four corner tables called lookup tables. The way that is being designed, you'll be calling it as like a star schema. So this will be communicating with all the four designs like item ID, region ID, and you can see sales provider partial ID. If we get into little bit depth into these kind of database schemas, then also we'll be talking about three most important things like primary key, foreign key, candidate key, super key, right? So in this, I'll just recall the difference between primary key and foreign key when I talk about this kind of databases. So primary key is the one which can derive all the other attributes of all which can derive all the other attributes in a given table. That is primary key. So foreign key will be acting as foreign key will be helping you to derive the data from other table, and the other table primary key will be your foreign key, right? The primary key of table A can act as a foreign key for table B. That is the difference between this and that. Okay, so data warehouse is star schema, right? And next one. Data warehouse access. So data warehouse is the last one. We have seen four key elements, right? In that four key element, the last one is data warehouse access and its application. How the access can be get made from it. A the main, the I mean like the major use of data warehouse is to to analyze and to share reports from the data warehouse. Again, let us consider the same example like a sales performance report. How what are the dimensions considered in it? How it is planned? How come it is performed? And I told you like the data warehouse should not be like on fly basis. It should not be like mostly designed. Mostly don't prefer or don't try to use the data warehouse system for doing some ad hoc things like doing plasma ad hoc queries and these kind of things. But until unless it required, we can go for this ad hoc queries and internal data. And third one, data mining purposes. So data mining purposes, what is that exactly we will be doing with data mining? How this data mining supports and works with the data warehouse? This will be discussed in the next topic, data mining in the next topic, right? So as I told about what is called, now we'll be getting quickly moving on to data warehouse to data mining. Like I told you the evolvement of this term, right? So data from initially data, then data set, then data warehouse. If you want, you can include data mart. So which is subset of data warehouse. So once after this data mart is done, data warehouse is done, then you'll be getting into data mining. Once data mining is done, then I will be getting into the next term called big data. See, as of now, we have discussed about all this data warehouse, database, everything, right? All these talk about structured data. Even my data warehouse, if I which is which is holding in a multiple databases. I mean, data warehouse can hold multiple databases. All this will be structured, will not be unstructured, and it make clear that this data warehouse can process and can hold things in an unstructured data set. Even if I'm doing some kind of data, some kind of analytics on this, it is also again it is going to be structured, which will not be unstructured. If you want to make use of unstructured data, you should make sure that unstructured data is converted to structured data, and then you can apply these kind of things. But next thing is if you want to do some kind of analysis directly on the unstructured data set, then where only big data works. That is what the difference between that big data and this data warehouse, right? But both this data warehouse and this what we call big data, everything is connected to BA. And let me a minute. There are few students are waiting. See, one more thing, like from the, I hope this is informed to you or not. You will not be allowed to log in. I will not be allowed to access the class in online. I mean, after 10 minutes. If you're late for the class more than 10 minutes, you will not be allowed for the class. This will be get followed from the next class. Not even for my class, it is common for all the classes. So you will be given 10 minutes time in the beginning for you to get login into it. If there is any network issues and you are trying to log in, if you're trying to log in again, so then some cases that is permitted. But mostly I think so, even if it is some network issues, this platform will be getting restarting, I think so. So let's look into that later. Okay, I'll be just recalling the meaning of data mining, then we can have some discussions, and then we shall start with the data mining in depth. So data mining is the art and science of discovering knowledge, insights, and patterns in a given data. Like so, data mining is a multidisciplinary field. This we know everything, right? So even we have discussed many things about data mining. So mining, extracting information. If I'm doing data mining, what are the things that I do with data mining? So here the term comes like association rule. We talk about association, right? Association and algorithms that works with data mining. The next most important thing is classification. Next most important thing is clustering, and next one is regression. These are the four major areas where we will be fitting this data mining: association, clustering, and again it is classification. Association, clustering, classification, regression, and these are the four major areas. From this I will be getting into the next thing called prediction. I can you apply this on prediction, but I can't tell you like all the four can't be get applied for predictions, only few works, right? So these are the four things that you want to know about it, right? Again there is one more term called supervised unsupervised data. I mean supervised data, unsupervised data, trained data, untrained data. So these things let us we shall discuss in the next upcoming topics. Like you can see as example, like customers who buy cheese and milk also buy bread 90% of the time would be useful pattern for a grocery store. I mean, like when if I apply this for a grocery store, I mean, like if they are making use, if they are selling this cheese and milk, so the chances of getting bread also purchased along with this is also a little bit 90%. Then the grocery store can purchase few more breads and make it to be available for the selling item to be get sold. So it is one strategy of it. And similarly, the blood pressure, and even you can see some kind of medicine. So whatever that medicine that they use, for example, like if you get into medicines for diabetics, you can see some few more medicines, a few more tablets will be get sold along with that particular item. So gathering and selecting data, how to gather a data and how to select the data and how to process the data. And we talk about data warehouse architect repository, and that it has to be get analyzed. It has to be get done either on a regular time intervals, either on hour basis or on a time basis or on a week basis. That which we have discussed. And to learn from data, one needs to effectively gather quality data, clean, organize, and use it. Like one requires skills and technologies for consolidation. That is what the skill, as I told you, like a data scientist. Earlier, we don't have the term data scientist. Once data science has evolved, we use a term called data scientist. And earlier, it was like a data miner. We call the term as miner. See, unstructured can come in any form of database like blogs, images, videos, and chats. So, doing from this is the most challenging thing from unstructured data. So, when you ask proper structured data, I mean, like getting into the proper insights will be a little bit good. So data cleansing and preparation. Once if you're getting into that, how data cleaning can be done. If you take what I can do is see a data mining is only a single topic. It is not a subject for you. It is, even data mining is It is a huge area. I will upload a textbook of data mining by Camber. So that is the most famous textbook for data mining. And just have a quick glance on the data mining book. Or just you can concentrate on the part like data mining process. You can see the data warehouse data mining will be given in a three-tier architecture. I mean, a three-tier architecture means as you talk about the front and middle and the three-tier architecture. Just quickly recall those things. And also you can see, I mean, the major things in the textbook. You can talk about a clustering, classification, regression, association. All these things will be there. You can just have a brief idea about what exactly data mining is doing, what are the things we need to familiarize in data mining. So since that is only a topic for us in the module 3, we'll be talking about the basics of data mining. We'll not be talking about the advanced things getting into data mine, how data mining works and what are the things we are doing. That is alone we will be doing. So data cleaning and preparation. So if I want to, I should before making my data allowing into a database, make sure that it should be good and strong enough. I should remove all the noises from my data set. And I should make sure that if it is structured data, all the data belongs to the data field which is of value. If it is a name and if it is given a integer of, I mean, if it is given the type of character strings, I should make sure that no integers being fitted, no integer is being allowed to enter in this data field. And also we use a term called data dimension, right? So duplicate data need to be removed, missing values need to be filled in, or else it has to be removed. Data elements may need to be transformed from one unit to other unit, like from one to other. This is almost always common. Like one data field will be having relation with the other data value and continuous values. And the next one is like a data elements may be adjusted from them comparable over time. Currency values may be adjusted over inflation. And all these things let us discuss with an example. So what is outlier data element? See outlier, you know the meaning of outlier, right? When I go for clustering, I will be grouping the most common or a set of related items into a group. I can see few data items which will not be getting falling into any groups. They will be those are called as outlier data elements. And there are some researches are there like what you can do with outliers, what can be done with outliers, and what in what way you can make the outliers to make it use. So there's a few research going on those things. Like so, outlier data elements need to be removed, right? Outlier that is what the meaning of outlier, which does not fit into any kind of any groups. So even if we talk about a cluster, is a group of similar elements, is a group of similar data items that can be just grouped into cluster. So these data items will not be getting fitting into any clusters at all. That is called outliers, right? And second one, if any there is any biases in the selection of data should be corrected to ensure that it should be good for taken for analysis. Third, as I told you, like getting into an proper high level insights, granularity to ensure compatibility and increase the density increase the density level of the data warehouse that we use in it. Okay. So outputs of data mining. If you see, like if you look into it, you can see data mining technique can serve for different purposes. One of most popular form of data mining output is a decision tree. If you talk about decision tree, it is not just a drawing a tree with a root node, left node, and the right node. So if we talk about a decision tree, it should be having a proper attribute and it should be having a proper condition based on that what a decision can be taken. That is how your decision tree works. And if you talk about decision tree, there are n number of decision tree algorithms available in data mining. In this, the most well known is it is called ID3, iterative decomister 3 algorithm. It is ID3, and also you can see CART 4.5, and you can see few more algorithms. And I have seen two or three assignments from your class which is using ID3 algorithm, right? So I asked you to develop the student performance evaluation system using data mining technique. So it means you need to design that system. You can design the system using this decision tree. It is also one possible solution for it, where you can design the student evaluation system with the help of a decision tree concept. So it is one most important thing in data mining. And second, it can also be a model-based decision. It can also be data-based decision. It can also be database driven decision. Okay, so this is in short about data mining. So almost that is 250. It is the meaning of it is I mean it is all about the introduction to data mining. So we shall be getting into in depth into data mining next class. Depth means again we'll be talking about the few things what beta mining is doing. but will not be getting into depth like what is called association, what is called classification, what a classification can do, what a prediction can do. All those things we will can do. We can take it as an advanced. I mean, you can take it as an if you want to learn about those things, you can have additional class. And similar parallelly, you just look into the textbook which will be get shared through Google Classroom to you today. That is a textbook name is Data Mining by Campbell. And just a minute, I will be just